pace today. Okay? Okay? So if my arc length is 30 and my central angle is 2 radians, then what is 15 is my radius, right?
Yeah, correct.
Okay? Because I need 2 groupings to get 30. Okay? And so 2 groupings of 15 gets me 30. Okay? Love it. Okay? So in trig, we can have a mathematical relationship between our 3 variables. Our 3 variables are s, theta, and r. And so that mathematical relationship is simply the arc length is equal to theta times r. Okay? So in words, this is the arc length the length along the outside edge of the circle, the perimeter of the circle, the circumference of the circle, whatever you want to call it. Theta is our central angle, and r is our radius. Okay? So our arc length is our central angle. In radians, that's the kicker, that theta has to be in radians in order for this to work. Okay? So, like for instance, you have a problem on that worksheet that you got yesterday that says that like the central angle is 24 degrees. Find the arc length. Okay? You can't do that using this formula until you convert 24 degrees into radians. Okay? All right? So that is key and essential to us. And now what we can do with that is we can mathematically solve for that. So for instance, if S is equal to theta times R, that means that theta is equal to S divided by R. Or that R is S divided by theta, which was the one that we just did in that last problem. Okay, where our arc length was 30, our central angle was 2 radians, so we said 30 divided by 2 is 15. That's how we got our radius of 15. Let's put these to work. So we've got a circle with a radius of 12 centimeters. A central angle intercepts an arc of length 18 centimeters. Find the radian and the degree measure of theta. All right, well, we can handle that. We can say that S is equal to theta times R. So our arc length is 18. We don't know what theta is, but we know that our radius is 12. So divide both sides by 12. Okay. So what's 18 divided by 12? 4/3?
3 halves.
3 halves?
18 divided by 12.
Both divided by 6? 3 halves? Yep, love it. Okay. So 3 halves here, radians would be our theta, right? Okay, that was in radians. Now we need to get that into degrees. So 3 halves times, now that's in radians, times 180 divided by pi. Well, that's going to be, let's see, 180 divided by 2 is 90, times 3 is 270 over pi degrees, right? Okay, so is approximately, I get 85.944.
You don't have to do the seconds.
It didn't say that we had to.
That's still. I don't know what.
So,
So how would you go from 3 halves to 85.944?
multiply 3 halves by 180 over pi. Convert it like we did yesterday.
Okay, but the equal sign down there, is that just like to minimize work?
Well, because it asks for both.
Is 3 halves radians equal to 85?
Yeah, that's what we just said. Yeah, because it asked for both. In the directions it said find the degree and the radian. So we had to find both. Yes, ma'am.
So, yesterday we said to keep it like in the,
Exact.
exact form, but so this is just kind of like the question.
The question will I will make sure on 2 Tuesdays tests that we specifically ask how we want it. Yep. Okay. You try this one. Find the length of an arc intercepted by a central angle of 3.5 radians in a circle of radius 8 inches. S is going to equal theta times r. What's my central angle? 3.5, and that's in radians, so I can use that. My radius is 8. 3.5 times 8, is that 28?
Correct.
So S, my arc length is 28 inches. Yes? Okay. Love it. Find the length of an arc intercepted by a central angle of 30 degrees in a circle of radius 12 inches. Ooh, I like this one. I will tell you that the answer is not 360.
Is this 6.28?
I don't know. Let's see.
Okay.
I haven't done this one yet. Okay. So S equals theta times R. What's my theta?
30 degrees.
30 degrees, but can I use that?
No.
No, okay. So we first got to take 30 degrees and multiply that by pi over 180. And that's going to give us what?
Pi over 6.
Pi over 6. Okay, my radius is 12. So then that's going to leave me with my arc length is 2 pi inches, right? Which is a lot cleaner than 6.2831, 6.283.
When will we have pi on the bottom?
No,
Oh, I would never go on the bottom.
no, now when we're changing it into radians. Ooh, I like this. Emory Sears Track at Bluffton College has running lanes that are 1 meter wide. The inside radius of lane 1 is 33 meters. How much longer is the inside of lane 5 than the inside of lane 1 around turn 1? Okay? So first off, we got to know what a track looks like.
Well,
Oval.
Oval track
It's an
or
oval.
circle track?
It's an oval. That's why we got to decide. How many people? Do we have any track athletes in here? Do you run on a circle or do you run on an oval?
We run on a track. Circle.
You run on a track, yeah.
No, we run on an oval.
You run on an oval.
But it
Okay?
should be a circle.
Hold on. Okay. So there is the inside of lane 1. Right? Okay, around the track. Now, what part of the track is turn 1?
The inside.
Make a left turn.
No, it's the bottom.
It's, you make a left right there.
So right there is turn 1, right? Right?
Correct.
Okay. So this is saying that this distance here is 33 meters. That's what that's saying. That's the inside arc of turn 1. Okay? So that arc length is going to be S is equal to theta times R. What is the angle that we went? 180, but can I use 180 degrees?
No, you
No.
gotta break it out. So it's gonna be pi.
So it's going to be pi. So the arc length of the inside of lane 1 is 33 pi meters. Right?
Right.
Each lane is 1 meter wide.
That's,
I
that's,
gotta go back.
that's
1, 2, 3, 4, 5. Where is the what is the radius for the inside of lane 5? Joe? 37. Do we agree with 37?
Yeah.
You tell me.
It's the inside. So it'd be the inside is 4.
the inside would be 4.
You have 5 lanes there.
So it's
Not using all 5.
But we're not
It's
using.
4.
Because so which one?
Subtract 1 is 4, yeah. 4 to 33.
So this is, right?
The
This
inside.
is the inside of lane 5.
You want us to count them all?
Yes?
Please.
Okay, so you ready? So if we're 33 there, then this would be
34, 35, 36,
37.
37.
I didn't
my
fight
gosh.
Okay.
Hey, let them finish it.
Yep.
Oh, you gave me too much.
I know.
You're too nice.
You have to multiply. So it would be multiple. You have to multiply. I'm not kidding.
So you guys basically said that the inside of lane 5, which is the outside of lane 4, has a radius of 37 meters.
Correct.
Okay? Which means that the arc length of that lane marker is 37 pi meters long.
Correct.
Correct? Okay? So how much longer is that arc length? So it's 4 pi meters longer.
I was right. I was right. But I was.
12.57? I almost did. 12 pi. 12.567. I remind you that on its learning, there is a video to watch. And so what I'm going to do is I am going to show you where that is. So if you go into pre-calculus, you are all registered in that. Okay? If you go to resources, actually you can go to your overview too, but we'll get it, I'll make sure that it's in the plans here momentarily too. But if not, you can go to resources, and then here's this week's, and it tells you right down here, video to watch prior to Tuesday. If you scroll all the way down to the bottom, here's the link to the video to watch before Tuesday. So it is, I think we figured it out yesterday in class, it's 11 minutes and 24 seconds to watch. And you should take notes on it prior to Tuesday's class.
Is that what the yellow sheet's for?
No,
Okay.
yellow sheet is homework.
Oh.
That's actually my